What's up, everybody? So I'm gonna do the chapter 18 because how the schedule worked out and all that stuff, having missed a couple weeks, we weren't able to do the class questions. So here you go, and then I will do another video right after this with the midterm overview so that we can be ready for our presentations tomorrow. Okay, so for chapter 18, this is metabolic pathways and energy production. So for this question, it says, which stage of metabolism involves the digestion of polysaccharides? And if we remember, um, we actually start to digest in the mouth, right? And so especially with the polysaccharides, so make sure that you're paying attention to that word there. And this you can find on page 620 in your textbook. And so since we can start doing the digestion in the mouth, that's actually going to be stage 1. Where is the site for the digestion of triglycerides? And that one is going to be in your small intestine. So where my cursor's doing this. So that's going to be C. He uses this silly thing almost every single day. You would think that it would like me, but apparently not so much. All right, oxidation of alcohols to produce aldehydes or ketones is done by which enzyme? Okay, so I'll give you guys a second to think about that one. Okay, and that one is going to be NAD+. It's going to be your correct answer. Okay, this one, so we really have to pay attention to the word net, okay? Because I talked about this in the videos and everything, but remember that glycolysis itself produces 4, but we use 2 to get the process started. So that is the weirdest 4. So 4 and then minus 2 to get it started. So that ends up giving you a net gain of positive 2. So just really pay attention to that word net, because that's going to get you if you're not paying attention. So it's kind of like, say my gross take home in a day is like $100. And then after taxes, my net take home is $2, right? Just kidding. But so just remember the difference between gross and net. Okay. In the first cycle of the citric acid cycle, first step of the citric acid cycle, how many carbon atoms are removed as CO2 from acetyl-CoA? Okay. And so basically, remember I talked to you a little bit about calculations and stuff, and how we can figure out rounds and whatnot is because we're going to be taking 2 carbons off the carboxyl end. So if we remember and we are looking at the anatomy of a fatty acid, right? So you're gonna have lots of carbons, right? And then you have your carboxyl group. I guess that would be an OH, and then maybe I might have gotten this one's OH, and then this one is just regardless. So, but you're going to be breaking at that beta carbon. Okay, so this is your alpha carbon, your beta carbon. So you're going to be taking 2 off of that carboxyl end. And so your answer is going to be 2. Okay. In stage 3 of metabolism, each glucose molecule that is metabolized produces how many ATPs, how many NADHs, and how many FADH2s. Okay, and so that would be where you'd have to again consult your book to figure out what they're saying are in the different steps, etc. But also knowing the ATPs is going to really get you where you need to go. Okay, and so in stage 3 metabolism, each glucose molecule is going to be producing 4 ATPs, 10 NADHs, and 2 FADH2s. In beta oxidation, a 14 carbon fatty acid goes through 6 turns of the cycle, and that is going to produce how many acetyl-CoAs before and how many ATPs. Okay, so if we have the number of carbons divided by 2, then that gives you the number of acetyl-CoA. Okay. And then the rounds is going to take that number, or the rounds is going to be the number of rounds times 14 is going to be the ATP, and that's going to get you in the rough estimate. Okay, so we have a 14 carbon fatty acid. 14 divided by 2 is going to give you 7 acetyl-CoA. Okay, and so right there, that would give you that answer. But if we take 7 times 14, then that's going to get you right around 84. So like I said, it might not be an exact number, but it'll get you in that that ballpark that you need. Okay, in one day, how many grams of urea are excreted in the urine by a typical adult? And this you can find on page 652. And this is annoying that I have to do this every single time to get my little pencil to be able to write. But if you look at page 652, then you will see that it's going to be 25 to 30 grams of urea. Total number of ATPs generated from the complete oxidation of glucose, combining both glycolysis, the oxidation of pyruvate, the citric acid cycle, and the electron transport chain is going to be what? In this class, and I've told you this in the video too, go by what your textbook tells you. So your textbook tells you 36. In my other life, it tells you 30. So always go by what your textbook is telling you for that test. And the reasoning is, guys, because science is an evolving thing, right? We calculate things a little bit different, and it's still a science, right? So it's not a law, it's a theory, and we're coming up with new ideas, etc. Okay, so for this class and this book, it's going to be 36 ATP. Which stage of metabolism involves the production of carbon dioxide? Okay, and again, that would be in the digestion stages that your book talks about. And in the yearbook, it says that that is going to be in stage 3. All right, this one is the powerhouse of the cell, i.e., where are we producing our ATP? And this would be the mitochondria. So that's a very common thing that we've learned from day 1 in science classes, right? So the mitochondria is the powerhouse of the cell, and that's where we're producing ATP. ADP and ATP molecules have nitrogen-containing bases called adenine and a 5-carbon sugar called ribose. ADP has 2 phosphate groups that are attached to the sugar, where ATP has how many groups? So I've always said from the very beginning of this class, always look for your root words. So ADP stands for adenosine diphosphate. So di means 2, where ATP stands for adenosine triphosphate, which is 3. Okay, so ADP has the di, or the 2 phosphates. ATP has adenosine triphosphate, or those 3. How many turns of the citric acid cycle are required to produce 72 ATP molecules? So remember, what we're going to do is that formula was going to be times 14, like the rounds times 14 would give you ATP. So you can do it backwards too. So if you do 72 divided by 14, that should give you 6, right? So 6 is going to be your answer. Alrighty. When enough carbohydrates are not available to meet energy needs, the body breaks down fat. Think of the keto diet. The oxidation of large amounts of fatty acids can cause what kind of molecules to collect in the liver? So basically, if we're breaking down fat, remember we count carbons and divide it by 2, and that gives you what? How many acetyl-CoA are produced. And so basically, if we don't take care of it, we're going to have a buildup of acetyl-CoA. So I guess the point of this one is try not to overthink the question know that you're talking about breaking down fats. We talked about that cycle. That's called beta oxidation. And so basically your end product of beta oxidation is acetyl-CoA. So again, don't overthink questions sometimes, because sometimes they are as straightforward as they seem. Okay. All right. And this is the last question. The breakdown of amino acids occurs primarily where? Okay, and that is going to be, a drum roll please, the last question of all of your biochemistry class for Baker for this semester. You guys know, it is going to be the liver. Alrighty, great job, you guys. It was fantastic having you guys in class today. Today, that we didn't have, but this semester, you guys all did fantastic. Very proud of you. We'll see you all for the class presentations, and I can't wait. We'll talk to you later. Bye-bye.